the point of the wicking bed is to demonstrate a technology that provides water from the bottom. So the slotted pipe at the very bottom is surrounded by gravel, has a shade cloth on top, and then there's 2 feet of compost. And the only watering that we do is through the pipes on the end. And so the water goes down underneath, and the capillary action of the water rising up through the compost is what waters the bottom of the roots. So these plants prefer to be bottom watered instead of top watered. And all of these plants were planted from seed indoor, and you can see they've done very well outside. I mean, they're 8 feet tall and climbing above the top of the vine. But we have tomatoes, a variety of tomatoes. We have cucumbers. We have marigolds to control pests. We have cucumbers. We have lemongrass. And we have citronella, again, part of the pest control. But one of the most interesting things is because we're feeding this, that's the whirligig that the vibration and the flashing from that keeps iguanas and birds away, as well as these little plastic snakes actually are a very good deterrent for iguanas as well. This kind of freaks them out for some reason. Don't know why, but it works. So the basic idea is to acclimatize the plants at their early stages and feed them with aquaponics water that encourages their natural autoimmune system. And so these plants, you can see we have no pesticides, no herbicides, and outdoor, and they're. Oh, yeah. So we have a bunch of different areas going on. Here on the right is our dark room where we do all the seeding and germination, and basically it mimics what happens underground. So this is our dark room, and we'll talk about that. Then we have, when they come out into the lights, we have both microgreens and our transplant area for moving it into the aquaponics system. Everything here is watered with 100% rainwater, and then we also have the aquaponics 5-level tier structure, and I'll talk in more detail about that. And then we have Dutch bucket system on the right, all of which is using aquaponics water, and then we have the rainwater system in the far back, and the fish tank and the swirl tank, which I'll describe in a little more detail.
Okay, so this is the dark room. There's really hardly anything in here right now because we pull it out usually on Fridays and we get it into the light.
And we just pulled out some Rambo radish, and we'll show you what happens when they come out of there.
Beautiful roots. They taste amazing. They grow up to grow them only in the dark so they don't get any green on them. And they're very, very tender, and they're wonderful, and you can eat the entire thing. You can eat the root, the pea, the stem, everything. So this is part of our educational process, is teaching people not to throw out stuff, because when we get the order for these from a restaurant, typically they want us to cut the pea off, and the pea is amazing. It's this wonderful, crunchy, nutty pea. So that's what we've just taken out just about a half an hour ago, and this is Rambo radish. And you can see we put a board on top. These boards weigh a lot. And the reason we do that is to make sure that the seed gets a really good root going down and a really strong stem. So these are typically 4 days in the dark. And that's the first time they've seen the light. So you can see them pop.
See them popping. Oh, the next one.
Yeah, so they're happy, and we just say, welcome to the world. Sheets, and we put a seed in, we keep it in the dark for 7 days, water only. Then we begin to water them with aquaponics water because they start to need nutrients after about the 7 to 10 day mark. So we use the aquaponics water directly from our system. So it's a closed loop system. Kendall will explain all of that. But this peat foam is really, really nice because it's super clean, and then we can sell things living. So when we pull it out of the deep water system, we can wrap the roots, and it comes as a living product to the consumer. Yeah, this is a really big seller for us. This is Oloroso. It's got a wonderful, fresh, delicate, little bit of crunch, but the flavor, the texture, everything is really nice. You can see the roots.
Most of them we have staged in the carousel. So
1 week at the beginning, second week, third week, and then here is when they're harvest ready. And so that simulates the carousel schedule so that every week we'll be harvesting from the large system in the same kind of structure. And I'll talk, and it's 12 inches deep in a deep water culture. And under this you can see the roots, beautiful white. And the water has a little yellow color to it because we just added iron. So we added chelated iron, which is giving it a little bit of that tint. But since the roots are surrounded by water, they get all the nutrients they need, so they're not sending a taproot. They don't need to fight for water. So all of the energy is spent growing up. So the majority of this happens in about half the time as traditional farming, and so we're cycling about every 28 days. So basil would typically take you 60 to 90 days to get to harvest ready, whereas we can get to this in 28 days. And again, every week, because we've staged it that way. So from seeds to transplant ready to transplants and then growing out in the grow troughs, you have the ability to cycle the growth like we're doing with the Little Rosso and the Paris and the Little Gem, some of the others. Simulate and take the pollen and pollinate each of the little berries. So it's pretty manpower intensive. And you can see it's beautiful, clear water, full of aquaponic nutrients that I'll talk about when we get over to the swirl tank and the fish tank, which is white Nile pearl tilapia. And we actually have 2 koi in the system. We got them as hatchlings, and they've been in the system now 2 months. Some of them are growing faster than others. But the nitrification process starts through when they exhale through their gills. There's ammonia that they create, as well as through their waste processes. It basically creates ammonia. So the ammonia is what is the engine for the nutrients in the system. So through the nitrification process, the first beneficial bacteria breaks the ammonia down into nitrites, and then the second beneficial bacteria breaks it down into nitrates, which is what the plants absorb. So the heavy waste materials are by gravity feed, go into the swirl tank. The swirl tank slowly rotates, so all the major sediments move out to the side and down to the bottom. And we actually capture through this drain all of the fish waste that becomes a super nutrient fertilizer for outdoor, and I'll show you that in a second. And this is where the bioactivation starts, and that was where it starts to break down the ammonia into the nitrites first and then nitrates. And then it goes down through that pipe and enters the system over on the other side where you saw the water flowing in.
So you said you have mostly tilapia, but you also said 2 koi. Is there a reason you...
The koi are actually really good algae eaters, and so they help keep the algae down in the tank. Okay. And if you notice, we have all around the system these air stones that are keeping the oxygenation. So the dissolved oxygen is really important in the system, not only for the fish. So we have a regenerative air blower here that blows the air up through the system and down into, we have 7 air stones in this system. But then the air line continues on, and every grow trough has 2 air stones in with the plants as well, because the roots need dissolved oxygen as well. And it all collects, I'll show you outside, but it all collects and comes in through that pipe and drops into this tank. And then it flows through, we have a manual trap to capture major sediments, and then it fills both tanks at the same level until it gets to the top, and then it overflows out to the outside. So once it's in here, then we use this pump down at the bottom to do the filtration, and it pumps through 20 micron, 5 micron, a carbon block, and then the last step is the UV filter, and then it turns into clarified water. So this is lacinato kale. This eventually will become all the bronze guard lettuce. Over here we have bok choy. We let this one go to flower to see the seed production. Eventually we're going to have our own seed library here. Again, the objective is to be a zero waste and almost a zero input facility so that we use the solar for power production, we use the rainwater for the water, and then we're actually growing our own food. Down at this end, it will be a continuous grow crop of 56 feet long. So it's 7 sections of the one inside there. So 7 sections long, and there'll be no break at the 8 feet. It'll be continuous grow trough 56 foot long.